So in this video, let's use our work on multiplication of polynomials to help us find the expression of the shaded region. And you'll notice that we have two examples, one that involves a shaded region within a square and one that involves a shaded region within a rectangle. We're going to take a look at that first example that involves the square. And you notice that the shaded region involves the inside area of the square. So area of a square is given by side squared. And notice that our figure is made up of two squares. We've got the larger square and then we've got the smaller square. And the larger square has side x plus 12 and the smaller square has sides of length x. And what we're doing is that little smaller square is like acting like a little hole. So it's like we have a square donut. And we're trying to find the area of the donut, taking out the square. We are going to need to figure out the area of the large square, and we're going to need to figure out the area of the small square. And because the small square is the hole in the donut, we're going to subtract its area from the bigger square's area. So the area of the large square is given by x plus 12 times x plus 12, or x plus 12 squared, isn't it? Side squared. And we know that that's going to be equal to x squared plus, now do you remember we did some work on squaring a binomial, and we know that the middle term is going to be twice the product of these two terms, 12x. We did some work on that. Go back to our video on special products and squaring a binomial. Then our last term is 12 squared. So we have x squared plus 24x plus 144. Now, if you don't want to square the binomial using the special products formula that we just talked about, the alternative is to write two copies of x plus 12 and use your FOIL method, as you know. All right, the area of the small square is pretty easy. It's x squared. So the area of the shaded region here, area of shaded region, what I'm calling the square donut, is going to be given by area of the large squared minus the area of the small square, because that's the whole. And so notice the x squared terms are going to give us 0. And so then we're going to have 24x plus 144. And these are square units because area is always in square units, and they didn't tell us in this particular problem whether these were representing feet or yards or inches or meters. So we write that the area of the shaded region is 24x plus 144 square units. Now in this example, we're going to find the area of the large rectangle, and that is given by this product, x plus 6 times x plus 5. So that's the area of the large rectangle. The area of the smaller rectangle, which is our hole in our rectangle donut, is going to be given by this product, x plus 2 times x plus 4. So that's the area of the small rectangle. So we're going to go ahead and FOIL these out. We're going to multiply those binomials, and then we have to do a bit of subtraction, don't we? So let's go ahead and multiply the first set of binomials using our FOIL method. And so we get x squared plus 6x plus 5x plus 30, or, and let's rewrite it down here, we are going to get x squared plus 11x plus 30 for the area of the large rectangle. Now let's FOIL and multiply the two binomials to calculate the area of the small rectangle. And when we go ahead and multiply, we get x squared plus 2x plus 4x plus 8, which is x squared plus 6x plus 8. And we're going to subtract these two to find the area of the shaded region. So that means that we're going to have to distribute this negative here. It's going to go all three terms in the second rectangle's area, which is that whole, right? So we have x squared plus 11x plus 30 minus x squared minus 6x minus 8. And now we're going to combine these like terms here, and we get 5x plus 22 square units as the area of the shaded region.